Hi guys, and welcome to today's video on quadrilaterals. Yes, what on earth is a quadrilateral? Well, fingers crossed you should know this because you've probably been dealing with it through junior school and now into secondary school. And what you tend to notice is that we repeat stuff over and over again. Why? Because repetition gets it into your brain and then you never have to worry about forgetting it. I mean, it's going to be so important walking down the shelves going, oh, a quadrilateral, kite, rhombus. Probably not. My name's MaffsGuru. Really good to see you. If you can, head over to YouTube if you can and subscribe and like the video. That's really important to me. There are lots more videos coming, and tell your mates and your teachers. Right, quadrilaterals. Let's see what we are working with today. So we're going to understand there's a difference between terminology called convex and non-convex. We're also going to look at the idea of that there are lots of different types of quadrilaterals: parallelograms, rectangles, rhombus, square, kite, trapezium. Yeah, all of these things share one thing. All right, they all have something in common. They have four sides. Awesome. Now the angle sum of a quadrilateral, really funky way of working that one out if you ever get confused, and actually it relates to other work in later videos, and use parallel line rules, easy for me to say, which have been covered in a previous video. So if you haven't watched that video, go parallel lines. If you're a Maffs Guru, search parallel lines, ka-ching, it should come up for you. All right. So let's get going. Convex and non-convex. Now it's weird, isn't it? Because everyone thinks that a parallelogram, or a quadrilateral all gets drawn the same way. There we go. Four beautiful sides, all straight, right angles in the corner. Thank you very much. Right angle, right angle, right angle, and right angle, and ka-ching, that's a quadrilateral. But in fact, it isn't. A quadrilateral is any four-sided shape. So when I tend to draw this on the board for my students, and I go, what is that? They go, it's a square. And I go, no, it really isn't. They go, it's a rectangle. And I go, no, it really isn't. And I get really picky because at the moment, that's just a four-sided shape. That's it. Nothing more, nothing less, right? One of those lines is a bit curvy. If I start putting right angles in the corners, then we can probably narrow it down now to either a square or a rectangle. You'll go, well, I need a square, the sides. But again, you don't know that. Sketches are literally that. Diagrams are just sketches. They're not accurate. We have to put information on it. If I now add these little lines here, now I can say with absolute certainty that that's a square. Why? Because those little lines mean that they are all the same length, or the sides are all the same length. So being able to identify by looking at the key characteristics, really important. So this is a quadrilateral, right? End of. Nothing more, nothing less. Now, as it turns out, this is actually a convex quadrilateral. The reason it's a convex quadrilateral is... The reason this is a convex quadrilateral is because all of the vertexes, another stupid word to introduce into maths, basically a vertex is a corner, all point outwards. And you're going to go, huh? And again, if you imagine that I am now putting little arrows on there, and you're going to say, arrow? I can't see any arrow. Well, now you can. There's an arrow pointing that way, and pointing that way, and pointing that way, and pointing that way. Well, ladies and gentlemen, all of those, imagine I'm inside one of those boxes and I'm trying to push my way out while I'm pushing on each of those corners. That is a convex quadrilateral. Hooray. What on earth would a concave quadrilateral look like? Well, something like this. Now, those of you who watch Star Trek, yeah, I know, probably that's a little sad on my part, but what can you notice there? Well, if we notice, if I was to look at each of those corners, those three are definitely pushing out, but this one here seems to be pushing in, right? So while I'm trying to get out, someone else is trying to get in. Oh, it's freaky, right? So in that situation there, that there is called a concave quadrilateral. So just some language for you to use. Does it change anything particularly exciting? Well, obviously that's not one of our special shapes, but it is certainly something to note. Just going to go back to this one here, because one of these is, this is the easiest thing in the world to work out how many degrees are inside a quadrilateral. Right? Because we have four right angles, we know that each of those right angles is equal to 90 degrees. And don't forget, these notes, everything I'm writing here now, you can actually download at maffsguru.com as a PDF. You can print it out, cut it up, all in color, and make your own notes, or at least build on them. Yes, each of those angles is worth 90 degrees. And because we have 4 of them, then we know that inside that quadrilateral, there are 360 degrees. Now you're going to turn around and say, well, yeah, but there's no way that that convex shape there is got 360 degrees. Well, it might surprise you. So let's draw it again. Let's just draw some random shape, all right? So that's obviously convex. It's obviously a quadrilateral. So now what I'm going to do is a bit of a funky trick. I'm actually going to draw a dotted line across from one vertex to the other. Doesn't matter which vertex. And you'll end up with 2 shapes. Yes? What 2 shapes do you have? Well, I've now split that quadrilateral into 2 triangles. Oh. What do we know about the angle sum of a triangle? Well, hopefully 180 degrees. So that means that that triangle there has 180 degrees. That triangle there has 180 degrees, and ka-ching! What do we notice? That 180 plus 180 is 360 degrees. So again, quadrilateral, 360 degrees. Angle sum of quadrilateral, 360 degrees. Ka-ching! Doesn't matter which quadrilateral, right? Doesn't matter which type of quadrilateral. All right, so now let's look at some types of quadrilateral. We've already come up with probably the most obvious one, which would be a square. There we go, there is my square. What do we know about the special points on a square? Well, first things first, we know that all of those sides there are the same length, or have to be for it to be a square. We know that the angles in the corner are right angles. Now, a great thing is, as well, is if I actually draw these lines here, which are actually called perpendicular bisectors, I know, then what we find out is actually they intersect at a right angle as well. And we know that all of these distance here are exactly the same. So ladies and gentlemen, there we go. That's the important information about a square. Moving on to a rectangle. Okay, so what do we know about rectangles? Well, they have 2 pairs of equal side lengths, right? So that little line there, single dash and double dash, means that those 2 there are the same length. They are the same length. What else do we know? We know that the corners are right angles there. And what I know is if I draw dotted lines from one side all the way to the other, then the lengths of here are all the same as well. But do not get tricked. These, hopefully you can see, but they do not cross at right angles, right? So they don't cross at right angles. That is a little bit of a trick. And another one, there is a rhombus. Now, what do we know about a rhombus? Well, obviously now the corners are not right angles. That's hopefully obvious. But we do know that these side lengths there are exactly the same. And again, if I was to draw dotted lines from one corner to the other, I know that this distance here and that distance there and that distance there and that distance there are the same, but actually, once again, they actually cross at right angles. So important. All of these different shapes we are going to use, right? But again, I think the most important thing to know is that for every single one of these, the internal angles is 360 degrees. Another really awesome shape that I love is a kite. All right, so we know that we have dotted line across there and a dotted line across there, all right? So that is once again going to meet our perpendicular bisectors, or our bisectors are going to cross at 90 degrees. What else do we know? We know that that length there and that length there are the same. These 2 lengths here and those 2 lengths there are also the same. One last thing to notice that's really important is actually that this angle here and this angle here are also exactly the same. Now that's only true of those 2 angles, because actually if you look at it, this thing here is actually a triangle. And if we notice, then on this side here, it's actually the mirror image of the same triangle. So what that means is that if this angle here is a certain degree, then it must make sense that that angle there is the same degree, right? But the others will not. So that's really important. Again, angles inside 360 degrees. And later on, when we get to the area, it's really funky, okay? So later on, when we find out the area of these things, what you do is you actually multiply the bisectors or the diagonals, and then we halve it. Yes. All right, and the last shape we're going to deal with is a trapezium. Now, if you have seen my video on parallel lines, you now know what those two lines there mean. That, ladies and gentlemen, means those two lines are parallel, and therein is a trapezium. Right, what do we know about the trapezium? Well, basically, that's it. If I were to draw dotted lines from one side to the other, doesn't tell us anything at all. Are the side lengths the same? No. All we know is that there is a quadrilateral, and we would know that the internal angles, again, are 360 degrees. Now, again, one of the things to notice about quadrilaterals is, one of the things to notice about trapeziums is that we can draw them in lots of different ways. So actually, this here is also a trapezium, right? Because we have a parallel side and a parallel side there. That is absolutely a trapezium. And we get tricked so often into making trapeziums all look the same. But I could quite happily have drawn my trapezium like this. That also is a trapezium. So you have to try and look for these type of shapes to help you find things like areas and angles and all those type of stuff as well. Yeah, so again, remember with trapeziums, we actually also can use our Fuzzock's rules. And if you don't want to know what I mean by Fuzzock's rules, there's a great video on that. All right, so they there are our shapes. We've covered the main. Right, now we're going to do finding angles. So here's my first angle, or first question. Thank you very much to Cambridge for allowing me to use their examples. Textbooks, the Cambridge Essential textbooks are by far phenomenal. They are literally the best out there. So how do we find this? Well, we have to go back to our Fuzzock's rules from before. And again, if you haven't watched that video, go back and look up the parallel lines visit. Don't look up Fuzzock's because I'm not sure we know how to spell it, but for reference, it's F-U-Z-X. That is my own made up term, ladies and gentlemen. So going back to this, what I'm first going to do is notice that because I've got a U shape in there, right, made up of some parallel lines, because again, oops, I missed the parallel lines. They are parallel as well. Because I have that, then I know that those angles there add to 180 degrees. So therefore, he does with my three dots, A would be equal to 180 degrees minus the 77 degrees. Notice how I'm putting down my working out. It is no good in maths just going straight and going, oh, I can work this out, yes? You just must do your working out. It's always given marks in maths. Now, you probably wonder why the calculator's at the side of the screen. It's just there for me to show you what a pretty funky calculator is. It's also for me to check my answers. Don't use a calculator to do these, really. Please don't use a calculator. I'm just doing it to check because I can't record these videos again. It's too hard. So as I say there, that comes out to be 103 degrees. Yay! How do I find angle B? Well, do you see the set of parallel lines I'm going to use now? Well, basically, it's going to be this set of parallel lines there. So what I might actually do is draw that part of the diagram again, because we know that angle there now is 103 degrees. We can find that angle there. Now, I always turn around and say it's never a good idea to use a calculation that you've already just done. If you cannot use it, that makes life a lot simpler. So let's just work it out because we're fairly sure we got that right. So we now know that angle B would be 180 degrees minus 103 degrees, which funnily enough gives me 77 degrees. And here is another really funky thing for parallelograms. We now know that the opposite corners have the same size. So actually I could have gone straight to that, written down my answer, particularly for B, and ka-ching, probably would only been 1 mark in an exam. I think this question here is a lot easier than the previous one. Strange that, isn't it? But what do we notice here? Well, we've got a quadrilateral. We know the angle sum of a quadrilateral is 360 degrees. So I know all of those angles must add up to 360 degrees. What they do is they try and trick you with that little sign in the corner. But hopefully you realize that that means that therefore we have 90 degrees there. Okay, so we can now find angle A by doing 360 minus 100 minus 115 minus 90 degrees. That's certainly one way of doing it. Other people actually would probably like to add all of those values together. So there's nothing wrong with that. So I can do 100 plus 115 plus 90, and that gives me 305 degrees. So we know that the angles in there are 305 degrees. So 360 minus 305 would give me 55 degrees, or as I say, I can do it on my 360 minus 100 minus 115 and minus 90 will give me 55 degrees. Both of those are exactly the same. And one last example, let's look at a kite. All right, so again, what do we know about the rules of a kite? So it's the opposite sides that are the same. And again, the way I tend to do that is I always draw the dotted line down the longest, just to make sure I've got where I know where my two triangles are. So I now know there is no working out here whatsoever. I can just write angle A is equal to 110 degrees. And ladies and gentlemen, that's the end of this video. Thank you very much for watching. If you can, subscribe, click like, tell your mates, tell your teachers, and hopefully I'll see you back again. There's a little bit more coming. Take care, stay safe. Bye-bye. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is MaffsGuru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.